Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X published on November 20th, 2025, about 5 days ago. It introduces an end-to-end system that turns a single text prompt into a fully traversable three-dimensional world, and on a reconstruction benchmark it cuts geometric error from about 0.04 down to 0.02, roughly a 40 to 50% drop. The paper is titled WorldGen, From Text to Traversable and Interactive 3D Worlds. And as we will see later, the implications for game and simulation creation are really exciting. Alright, Figure 1 gives a first glimpse of what this system actually produces, showing several snapshots of fully generated three-dimensional worlds. The figure presents varied environments, from medieval streets and stone ruins to deserts, snowy villages, and industrial yards, which demonstrates strong stylistic flexibility from the same pipeline. Each scene consists of separate, fully textured meshes, so individual buildings or props can be edited or replaced without touching the rest. Because the geometry is explicit and coherent, these worlds already support collision and navigation, making them immediately usable inside standard game engines. So, while Figure 1 showed the range of worlds, Figure 2 walks through how a single snowy village emerges step by step. Stage 1 plans the layout, turning the text prompt into a coarse blockout, a stylized reference image, and a navigation mesh that marks walkable space. Stage 2 reconstructs a full, low-resolution, three-dimensional mesh that respects this plan. Stage 3 decomposes that mesh into individual colored objects, and Stage 4 refines each object's shape and texture. The bottom row then presents first-person views, which confirm that the final scene is detailed, coherent, and ready to explore. Well, Figure 3 zooms in on Stage 1, showing how a short prompt like Mountain Village turns into a concrete three-dimensional layout. The large language model first converts the text into a JSON-style parameter list that specifies terrain steepness, verticality, density, and regularity. Those parameters drive the procedural generator, which creates the colorful coarse layout of terrain and building footprints. That layout is rendered into a grayscale depth map, which then conditions the depth-to-image model to paint the final mountain village scene consistent with the planned geometry. Alright. Figure 5 explains how the system turns images into three-dimensional meshes during Stage 2. The left asset Gen 2 architecture starts from a single conditional image plus random noise latents, runs them through a DINO encoder and a diffusion transformer, then decodes a detailed mesh with a VAE decoder. The right nav mesh conditioning branch injects both the top-down navigation mesh and the image so the generated scene geometry stays traversable and matches the planned walkable areas. So, after explaining how nav mesh conditioning enters the architecture, Table 1 reports how well the generated scenes actually match the desired walkable regions. The table measures alignment using chamfer distance between the input nav mesh and the nav mesh extracted from the final scene, where lower is better. The baseline asset Gen 2 variants sit around 0.04, while the proposed model drops to about 0.02, roughly a 40 to 50% improvement in navigation accuracy. So, after quantifying nav mesh alignment, Table 2 measures how well different methods break a scene mesh into meaningful parts. The metrics include chamfer distance, where lower is better, and several F-score thresholds, where higher is better, plus runtime. The three baseline models have chamfer distances around 0.14 to 0.17 and moderate F-scores, often below 0.65. Ours roughly halves the chamfer distance to 0.06, boosts the best F-score to about 0.85, and still finishes in about 1 minute. Alright, while Table 2 quantified numbers, Figure 9 makes the differences in scene decomposition very concrete. The left column shows the holistic gray meshes with no parts separated. The middle columns display three top competing methods, which either leave large regions undivided over fragment flat terrain or introduce noisy slivers. The rightmost column, labeled Hours, shows clean, semantically grouped colored parts across scenes, and the time icons indicate it does this in about 1 minute. WorldGen shows that a single text prompt can drive a full pipeline from layout planning to nav mesh-aware, three-dimensional diffusion, then fast decomposition, and per-object enhancement, producing game-ready worlds in minutes. The bigger implication is rapid, accessible world building for games, simulations, and social spaces. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.